Example 3 says give the equation of the line that passes through the point 18, 3 with a slope of 1/9 in slope-intercept form and in standard form. So let's start off by creating our equation in slope-intercept form since it already gives us the slope. That means that our equation will look like y equals mx plus b, but because we're given the slope being 1/9, we just have to figure out what b is. Now, we know that the line goes through the point 18, 3, and 18 can be thought of as the x-coordinate, and 3 can be thought of as the y-coordinate. Since we have that point, we can plug those values into our equation to solve for b. So I'm going to go ahead and replace y with 3 and 18 for x, and we just don't know what b is, so that's what we're going to try to solve for. So 18 times 1/9, I would just multiply across. So 18 times 1 is 18, 9 times 1 is 9, and 18 divided by 9 is 2, so I could simplify that. So now I have 3 equals 2 plus b. I can subtract 2 from both sides, and I would get 1 is equal to b. So that can be replaced here. So let's go ahead and plug that in. So our answer, our equation in slope-intercept form would be y equals 1/9 x plus 1. And to get that into standard form, we would want to move anything over to one side that has like the x or the y. So I'm going to go ahead and subtract 1/9 x from both sides. So that will cancel out on the right-hand side or give us 0. So on the left-hand side, we will be left with negative 1/9 x plus y is equal to 1. So this is our equation in standard form. Okay. Example 4 wants us to fill in the blank values within the table using the linear equation y equals negative 3/2 x plus 4. So here we know that the x value is negative 2, and we are trying to figure out the y value. So why don't we plug in negative 2 for x? So we'd get negative 3 over 2 times negative 2 plus 4. And to simplify that, I could rewrite that as negative 2 over 1. And if we multiply across, we would get y equals 6 over 2 plus 4. 6 divided by 2 is 3. And if we add 4 to that, we would get 7. So I'm going to go ahead and fill that in. Our y value is 7 when x equals negative 2. So now we want to figure out what our y value is when we plug in 0 for x. So y equals negative 3/2 times 0 plus 4. We know that a number times 0 is just 0. And 0 plus 4 is 4. So that's going to be 4. Hopefully you might say to yourself, hey, this looks like it might be the y-intercept. And if you said that, you would be correct. So for this equation, the ordered pair 0, 4 would be the y-intercept. Now, in the next row of our table, our y value is 6, and our x value is the thing that we want to solve for. So I'm going to set y equal to 6. And our goal is to solve for x. So from here, I'm going to subtract 4 on both sides. So I get 2 equals negative 3 over 2 times the quantity x. And from here, I'm trying to get x by itself, so I could multiply both sides by 2, and those 2's would divide out, and so we would be left with 4 equals negative 3x. And then my last step, I would divide both sides by negative 3, and so we would get x equals negative 4 over 3. Okay, last one, we want to figure out what the x value is when y equals 12. So 12 equals negative 3 halves x plus 4. I'm going to subtract 4 from both sides. And if I do that, we get 8 equals negative 3 over 2x. And just like in the previous example, I can multiply both sides by 2. And if we do that, the left-hand side will be 16. And the right-hand side will be negative 3x. And then we can divide both sides by negative 3. And we'd get x equals negative 16 over 3. So I'll go ahead and put that in my box as well. So we've filled out the entire table there. Example 5 wants us to graph the linear equation y equals 5 over 7x plus 2. Notice that this is in slope-intercept form. So when you have a linear equation in slope-intercept form, it's often helpful to identify the following two things: the slope, which in this case is 5 over 7, and the y-intercept, which is 0, 2. So I'm going to graph in green. The first thing that we want to do is we want to plot our y-intercept, which is here at 0, 2, and the slope is our constant rate of change. So the 5 represents our rise, so rise over run. So we're going to go up 5 units and then to the right 7 units. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. If I went up another 5 from there and then right 7, we would be falling off of the grid. But what you could do is you could start at your y-intercept again. If you really wanted a third point, you could go down 5 units and just go in the opposite direction. So you could go down 1, 2, 3, 4, 5, and then from there you could go left 7 units. 1, 2, 3, 4, 5, 6, 7. So I'm going to plot a point there. And I'm going to erase those little dots that I made because those are not part of our graph. And now I can use a ruler to connect those 3 points that we have there. And I'm going to put arrows to indicate that that goes on forever in both directions. So there we have the graph of y equals 5 over 7x plus 2. Example 6 says, graph the linear equation x minus 2y is equal to 9. Now, notice that this equation is not in slope-intercept form. We could put it in slope-intercept form, and that might make things easier to graph for us. So I have x minus 2y is equal to 9. I want to solve for y, so I'm going to subtract x on both sides. And if I do that, we have negative 2y is equal to, I'm going to swap these two terms, so it's negative x plus 9. And then from here, I want to divide both sides by negative 2. So these will divide out, and we'll just be left with y equals negative x plus 9 divided by negative 2. Now, when I was taking algebra, my algebra teacher would say that we simplify this by using a heart. So I'm going to draw a heart like this because we have to divide negative 2 into both of these terms. And if you draw that, it kind of looks like a heart. So y equals negative x divided by negative 2 is just 1/2 x. The negatives cancel each other out. And then 9 divided by negative 2 is just minus 9/2. Okay, and let's identify the slope and the y-intercept. So our slope is 1/2, and our y-intercept is 0, negative 9/2. And if it helps you, you can also convert that to a decimal. So that's the same thing as 0, negative 4.5. So let's plot our y-intercept first. So I'm going to go down 1, 2, 3, 4, and then like halfway between negative 4 and negative 5. So that'd be about right there. And then our slope is 1 over 2. So I would go up 1 unit over 2 units, up 1 unit over 2 units. And then I'm just going to pull out my ruler so that I can connect those. So my graph would look something like that.